Good morning, student. Myself, S.P. Kelkar, math teacher from Dan Prakash Vidya Mandir, Aurangabad. Now, yesterday we have seen already the inscribed angle and intercepted arc. Now, today we are going to see the inscribed angle theorem. The measure of an inscribed angle is half of the measure of the arc intercepted by it. It means that the measure of angle is equal to the half of the intercepted arc. Now given in a circle with center O, angle BAC is inscribed in an arc BAC, this arc, then angle BAC intercepts an arc BXC. This arc is intercepted by this angle BAC of the circle. To prove that measure of angle BAC equal to 1 by 2 measure of arc BXC. Measure of arc BXC means measure of this angle BAC equal to 1 by 2 measure of arc this BXC. Now proof. There arises three cases. For this proof, there arises three cases. First case, the center is on the angle as in the figure, join C to O. Now the center is on the circle means the center of circle lie one of the side of the angle BAC. Means this center lie on the side, one of the side, that is the side AB or AC. From these two sides, this center lie on the one of the side, that is the O. Then join C to O. Then triangle AOC is isosceles triangle. See this triangle AOC. AO and OC are the radius, so we can say that this triangle is isosceles triangle because AOC equal to OC, radius of the circle. Then angle, measure of angle OAC equal to measure of angle OCA. This angle and this angle measures is equal to P, and the measure of these two angles are same because these two angles are the angles opposite to the congruent side. Then measure of angle BOC means this angle equal to measure of angle OAC plus measure of angle OCA, means measure of this angle equal to sum of these two angle. That is the remote interior angle theorem. Then we write down here measure of angle BOC equal to P plus P, means we take measure of these two angle equal to P, then P plus P equal to 2P. Then we can write down measure of angle BOC equal to twice measure of angle BAC, means we take one of the name from these two, BAC, twice, means this angle measure equal to twice of this angle measure. Then measure of angle BAC equal to 1 by 2 measure of angle BOC, means measure of angle BOC equal to twice measure of angle BAC. Then this 2 goes to the left side, it's divided to measure of angle BOC, means 1 by 2 measure of angle BOC, means measure of angle BAC, the measure of this angle equal to 1 by 2 measure of angle this BOC. But measure of angle BOC equal to measure of arc BXC, definition of the measure of minor arc. By the definition of a measure of a minor arc, we can write down the measure of this angle equal to the measure of this arc. Then we write down here measure of angle BAC equal to For this measure of angle BOC, we can write down here measure of angle arc BXC. Then measure of angle BAC equal to 1 by 2 measure of arc BXC. Then case second, the center is in the interior of the angle, means the center lie inside the angle. We take center inside of the angle BAC. The center is in the interior of the angle. The diameter drawn through A. The other endpoints is D. Now the diameter drawn from A and other endpoint is D, which is passes through the O. The diameter always passes through the center of the circle. So AD is the diameter. In first case, we proved that measure of angle CAD. Measure of angle CAD means center lie on the side of the one of the side of the angle. That is we prove here that measure of angle BAC equal to 1 by 2 measure of arc BXC. Then we write down directly here measure of angle this CAD equal to 1 by 2 measure of arc this arc CMD or DMC 1 by 2 measure of arc DMC. Then measure of angle DAB this angle. For this angle also center lie on the side of the angle. Then we can write down measure of angle DAB equal to 1 by 2 measure of arc DNB. Measure of angle DAB equal to 1 by 2 measure of arc DNB. Then we take sum of these two angle. Measure of angle CAD plus measure of angle DAB, we get here 1 by 2 measure of arc DMC this plus 1 by 2 measure of arc BND, means sum of these two. We get here, we take common 1 by 2 from these two, in bracket measure of arc DMC plus measure of arc BND. Now sum of these two arc means this arc plus this arc is nothing but CXB, means arc CXB or arc BXC. Then we write down here 1 by 2 measure of arc BXC. We can say that arc addition property. Then in case second, the center is in the exterior of the angle, means this center outside the angle, means the center lie here or here outside the angle. Let D be the other endpoint of the diameter drawn through A. Then we again draw the diameter which is started from A and the other endpoint is D. See again. Now in third case, the diameter drawn from A, the other endpoint is this. Now this center lie outside of this triangle BAC. Here the center of circle, then we draw the diameter AD. Now as proved in the first case, we have measure of angle CAD, this angle CAD. Now here center lie on the one of the side of the angle. Then we write down measure of angle CAD equal to 1 by 2 measure of arc this. We can write name of the arc CMD, which started from CMD. Then measure of angle DAB. See this angle, measure of angle DAB equal to 1 by 2 measure of arc BND. Started from this B point ND. Means measure of angle DAB equal to 1 by 2 measure of arc BND. Now if we subtract from this equation this equation, that is means measure of angle CAD minus measure of angle DAB. Measure of angle CAD minus measure of angle DAB equal to 1 by 2 measure of arc CMD minus 1 by 2 measure of arc BND. Now take 1 by 2 common from these two. Measure of angle, see the subtraction of these two means CAD minus this angle DAB. Means we subtract from this angle this much angle, we get here angle again BAC. We write down here measure of angle BAC equal to 1 by 2 measure of arc CMD minus measure of arc BND. Now from this subtraction from this arc CMD minus BND, we get here arc CXB, BXC. Now we can write down here subtraction of these two arc equal to 1 by 2 measure of arc BXC. This much arc is remain. Then in this way we prove here the measure of angle, inscribed angle equal to half of the its intercepted measure of arc, half of the measure of arc which is intercepted by the angle. Now here corollaries of inscribed angle theorem. In this corollaries, angle inscribed in the same arc are congruent. See in this figure angle ABD and angle ACD, these two angles are inscribed by this arc ABD. Means the same arc inscribe the two angle, then we can say that the measure of these two angle, or we can say that these two angles are congruent. A circle with center O, angle ABD means this angle, and angle ACD means this angle are inscribed in a arc ABD and intercepts arc AXD. These two angles intercept the arc AXD, which is also same. To prove that angle ABD congruent angle ACD, proof. Angle ABD equal to 1 by 2 measure of arc AXD, that is the inscribed angle theorem. This statement is written by inscribed angle theorem, equation number 1. Then angle ACD equal to 1 by 2 measure of arc AXD. Then from 1 and 2 we can write down angle ABD congruent angle ACD from equation 1 and 2. Angle inscribed in a semicircle is a right angle. Now that is the second corollary is angle inscribed in a semicircle is a right angle. See in this figure the AC is diameter and this angle ABC inscribed in this semicircle. Now given a circle with center O, segment AC is the diameter, angle ABC is inscribed in the arc ABC, this arc ABC, and intercept an arc AXB. Now to prove that angle ABC equal to 90 degree, ABC equal to 90 degree, proof. Measure of arc AXC equal to 180 degree. Number 1 equation, measure of semicircle. Now this is the semicircle, so we can write down 180 degree measure of semicircle. Angle ABC equal to 1 by 2 measure of arc AXC. Inscribed angle theorem. This angle is inscribed angle. Then we can write down angle ABC equal to 1 by 2 measure of arc AXC, which is intercept by that angle. Then we write down here measure of angle ABC equal to 1 by 2 into 180. Measure of this AXB is 180. 1 by 2 into 180 we get 90. Angle ABC equal to 90 degree. In this way we can prove here that the angle ABC which is inscribed in a semicircle is 90 degree. In this way we complete this corollary, two corollary. Now yesterday we have complete a 3.3 practice set. In that practice set there are 3 examples. We take already one of the example. You can complete it. Good day, goodbye, okay.